Hello, breakout counter students. Mrs. Myers here. Today for Chapter 7, Section 4, Day 4, we are going to pretty much just do a review of solving a word problem by writing a system of equations and by solving that system of equations using an augmented matrix. So hopefully this will go pretty quickly, and I only have 2 problems for you to do for your homework, and it's just 3x3 systems, the way this is a 3x3 system. Okay, so let's just do a review here about what is necessary when solving a word problem. First is we have to write let statements for the unknowns. Okay, so read through this word problem, please, and copy it down into your notes. Pause the video, if you need to do that, and then restart it once you're done. So anyway, we've got 3 different unknowns here. We've got an amount of money that is going to be invested at 7%. And we've got an amount of money invested at 9%. And lastly, we have an amount of money invested at 11%. Okay, notice that I was clear with those let statements. All right, you don't want to be, too generic with them and just say, X, Y, and Z are 7%, 9%, 11%. What is it that, the X, Y, and Z are, really representing? Okay, it's the amount of money invested at those percentage rates. Okay, so now because we have 3 different unknowns or 3 different variables, we need 3 different equations. So we're going to look at the word problem and find 3 different pieces of information that allow us to write 3 different equations. So first, the inheritance was $40,000, so we're going to just say X plus Y plus Z is equal to $40,000. And it says that the investments yield $3,500 per year. So you're going to take 7% of X. Okay, you're going to take 9% of Y, you're going to take 11% of Z, so just change those percentages to decimals, and that is going to give you $3,500. And lastly, we read that the amount of money for the second investment, which is the 9%, okay, so the Y is $3,000 less than the first investment, which is at 7%, so that would be Y equals X minus 3,000, okay? So now to set up an augmented matrix, though, what is important is we got to take this equation and we got to get it into the X, Y, Z equals a constant form. So I'm going to minus the Y and equal to 3,000 here. So I'm going to change this to X minus Y equals 3,000. And now I can set up my matrix. All right, so I've got the first one, for the first row of my augmented matrix is just going to be 1, 1, 1, and then 40,000. Second row is going to be 0.07, 0.09, 0.11, and 3,500. And then the next is going to be 1, -1, 0, and 3,000. Now what I'm going to do right off the bat is I don't like working with those decimals, so I am going to take row 2 and I'm going to multiply it by 100. Okay, just so I don't want to have to work with those decimals. Okay. So that's going to be 7, 9, 11, and 350,000. Okay, so anyway, here's what I'm gonna ask you to do for your homework for the 2 different 3x3 systems. So I'm going to ask you to solve one by Gaussian elimination, which means get your augmented matrix into row echelon form and use back substitution, and then to pick the other one and do reduced row echelon form, which is basically Gaussian-Jordan elimination. So they both start the same way, which is, envision where you are going to want that diagonal of 1s to be and get the zeros below it for sure. So we're going to start with those 2 entries right there. And I'm just going to recopy the first row because I'm not going to change that at all. And, just make sure that you use 2 different row operation statements to get these 2 spots to become a 0. So I'm going to start by saying row 2 plus -7 row 3 to get that to become a 0. And then I'm going to do row 1 plus row 3 to get that to become a 0. Okay, so we've got 7 on -7, obviously there's a 0, 9, and then this is going to be plus 7, there's your 16. We're going to have 11 plus 0, so that's going to stay 11. And then it's going to be 350,000 minus 21,000, and that is going to become 329,000. Okay, and now here we're going to do row 1 and negative row 3, so that's going to become 0. So 1 minus negative 1, meaning 1 plus 1, there's your 2. 1 and 0 is going to stay 1, and 40,000 minus 3,000, and that is 37,000. Okay, so again, envisioning where you eventually want that diagonal of 1s to be. Now we're going to get that entry to become a 0. Okay, and notice that each time, again, just as a quick reminder, because I was starting to see some things on some previous homeworks, is I'm writing my row operation statements beside the row that has changed. Okay, not beside the row that I want to change, but beside the row that has changed. So this row operation statement explains where this row came from with respect to the previous matrix. You must write those row operation statements in the correct spot. All right, and not putting them in the right spot is you not doing the correct work. Okay, so that's very important that you do that. So anyway, I'm going to recopy the first row as is. Okay, second row as is. And now I want that to become a 0, and I want to keep this 0, which means I have to use row 2. So I'm going to say row 2 and negative 8 row 3. All right, so that's how that would become a 0. So that stays 0, that becomes 0. And then we've got 8 minus 11, which is 3. And then 329,000 minus 8 times 37,000. Of course, put that in your calculator there to help you out. And that would be 33,000. Okay. Now, as per our row echelon form is considered, Gaussian elimination and back substitution, I think it's okay for you to actually stop right here, and then you would just start taking your rows. So you'd say row 3 is 3z equals 33,000, and now you have an answer for z. Okay, then you would take row 2, which is saying 16y plus 11z equals 329,000. Okay, and you're going to back substitute with your value of z, which is 11,000. Okay, and then you would do all the solving, and you'd get yourself your answer of 13,000. And then you'd finally go to row 1, which is the original equation of x plus y plus z is equal to 40,000. You would back substitute with the y, which is 13,000. Right? You'd back substitute with the z, which is 11,000. All right. Sorry. And then you'd solve for your value of x, so 24,000. Okay, we'd minus 24,000 from that, and we'd get 16,000. Okay, and then those are your answers. Now, if you're doing Gaussian-Jordan elimination, which if it's okay, I'm not going to continue doing that here in the video because I've already done it with you. I'm trying to keep this short. Is you would continue with getting the zeros. First, you would do these entries here and here to become the zeros, and I would just suggest use row 3 to do that each time. Okay, then you would finally get that spot to become a 0, and then you'd have your ending with your diagonal of 1s. You could do those row divisions, right away or save them to the end, depending on how big or small you wanted to have those numbers be working with. And you would then wind up having your final matrix. Okay, I'm just going to write it here. Okay, obviously it would be 1, 0, 0, and your answer for x would be 16,000. Okay, and then you would have 0, 1, 0, and your answer for y there would be 13,000. And 0, 0, 1, and your answer for z would be 11,000. Okay, so after you continue getting those zeros and doing those row divisions in any, whatever order you want, okay, this would be what your final matrix would look like for reduced row echelon form. And then you'd simply have the same exact answers that you already had. All right, so again, I'll be putting this in the directions for the homework, but you have 2 word problems to do. Each is just a 3x3 system. Pick whichever you'd like to do by, Gaussian elimination back substitution, meaning get row echelon form like this, and then pick the other to do Gaussian-Jordan elimination, which means get the matrix all the way to reduced row echelon form, and then get the answer. Okay, so just one of each. I hope all is going well with everybody, and let me know if you have any questions on this. Okay.